This proof is so important, it's come up in at least 2 past papers, and it's even got its own name, called the geometric arithmetic inequality. So let's prove that the square root of xy is less than or equal to x plus y all over 2. So for these type of proofs, I like to go from the bottom and work my way up, and then complete the proof by going back down. So the last line is going to be the answer. It's going to be the last line, it's like what we expect. What can we do from here? Well, we've got a square root, so let's try squaring both sides. The square of what's underneath the square root is just xy, and we want to square x plus y all over 2. And the left-hand side is still going to stay the same, but now we're going to square x plus y, which is x squared, plus 2xy plus y squared. And we're going to square the 2 in the denominator to get 4, which just about squeezes in there. Next, to rearrange, we could times both sides by 4. To get 4xy is less than or equal to x squared plus 2xy plus y squared. Now we might try and put everything on one side. So by subtracting 4xy from both sides, we're going to get x squared minus 2xy plus y squared. And if we read from right to left, this will be bigger than or equal to 0. Now we're going to try and put this into a square bracket because that's how a lot of these proofs work. We're going to have an x and a y, and then they're going to be minused in the middle. Now we're going to try and finish the proof from top to bottom. Why is this top line true? Well, anything squared is always bigger than or equal to 0. So x minus y squared must be bigger than or equal to 0. This will imply that the second line is true by expanding. This will imply that the third line is true by rearranging. Similarly for the next line by dividing by 4. More rearranging applies to the next line. And then the last line is true because we have square rooted both sides. We do want to make a little note. Even though it's only worth 2 marks, it's worth mentioning we can only do the last line as the square root because x and y are both positive numbers. A slightly quicker way, although I wouldn't have thought of it in the heat of the moment in the exam, would be by first considering the square root of x minus the square root of y squared. The reason you can consider this is because if x and y are positive, you can take the square root of them. Now this thing is squared, so just as before, it's going to be bigger than or equal to 0. This implies that if we expand it, we're going to get x minus 2 square root x square root y plus y is bigger than or equal to 0. Now by doing a bit of rearranging, we can move the 2 root x root y to the other side, like this, and then we can divide by 2. Now the only thing left is to put the 2 square roots together to say that the square root of x times the square root of y is the square root of xy. Here are 2 more exercises as well.